We'll go ahead and get started with our webinar. We are delighted to have Dr. Thorben Jansen here to present on some of his latest work, looking at generative AI and meta-analysis coding. Dr. Jansen is, I'm try to say this right, head of the junior research group, Genius, Generative Intelligence Utilized in Schools. It's part of the IPN Leibniz Institute for Science and Mathematics Education. So thank you so much. I know it's a very different time zone from where you're at, so we appreciate your flexibility and we're excited for your presentation.
Thank you, Colton. I'm also very excited to speak with you all about this work and, of course, more so what we're heading with it. And yeah, I brought 3 studies today that I like to introduce and discuss with you. And the overall title is Data Extraction by Generative Artificial Intelligence. And the starting point is here, of course, that the method we are all interested in is very flourishing. There are a lot of meta-analysis and systematic review coming up in the social sciences and health. And what we all very good know is that doing a systematic review and preparing a meta-analysis is very time consuming, and you have to put a lot of effort into it in numbers that take mostly about more than 12 months, very much financial resources. And one reason for that is that the extracting the data from each included manuscript is very time consuming and takes about 3 hours per study, which costs a lot and has the risk of incomplete or unreliable data extraction. So could there be a solution to that? And one could think, yeah, maybe it could be a solution just to put the data into a generative AI chatbot, and all what we did in 3 hours is now solved. But when we look at this, well, the first question that comes to mind is, of course, does this work? Does this say anything, this table, or is there something to it? And as it all came out in 2023, the general opinion was that this is not a solution. It does not work. The conclusion was mainly LLMs are not ready to use for data extraction. And this was based on quite rigorous studies, which were in a medical domain and mostly functioned the way that the authors take human extracted data, so the status quo, the business as usual, and compared them to data extracted by large language model and calculated the agreement between those. And when you look at the blue column, you see the agreement range between 34 and 74%. But what you maybe also notice is the studies are ordered in release time, so 2023 to late 2024. And there seems to be a little trend that the agreement was rising. And in the end of 2024, the first evaluation studies came out that showed quite different results and indicating near perfect accuracy and very low rates of hallucination, around 6%. And when we look at the literature in late 2024, you see the mean agreement goes into the high 80s%, meaning that in over 80% in those studies, the LLM extracted data was exactly the same like the humans do in the very time-consuming process. At this point, we indicated in the work some limitations of the literature. All the studies I showed on the previous slides were coming from the medical context, which could be a reason why they found so high accuracy, because in the medical domain, everything is so good structured and the informations are very clear. They focused on very few variables, which were all the same, like something about the population or the outcome variable. And what struck me the most was that they all looked only at the mean accuracy and did not provide condition where it's higher or where it's lower. So they were not about the conditions for accurate extraction. And so we started to get investigated in 3 research questions. So one, looking at psychological studies, comparison to the medical domain. Then we looked at what kind of errors do the large language model make and to what extent, and what are the conditions that seems to enable higher or hinder the accuracy. So our work was situated in the psychology. We tested multiple large language models against each other and a lot number of study. How we do that? How did we do that? So we used the same approach like the previous study. We compared AI-generated data with human-generated data. We took the human-generated data from 22 reviews, which published openly their data, and that the articles were published in Psych Bulletin. Like I said, we used 8 large language model and extracted data all in all from over 2,000 primary studies. And that's led to over 300,000 comparisons. So what now to the most interesting part, the results. When we integrate everything, so here you see all the LLMs, all the variables, and percentage agreement on the y-axis, and all the variables we looked at on the x-axis. And you see that there's a lot of variance in it. So there were a lot of variables which had very low agreement, and also about half that have such high agreement, about 70%, which we could use in a way in data extraction. When you look at the colors, these speak about what kind of variables were more extracted in higher accuracy or lower accuracy. And you get a feeling that the red variables, which are looking at effect sizes, had rather lower agreement than the more blue here shown variables that are describing the study as in more general, like the time frame and outcome population variables. When we take a look in more detail about which LLMs were better, is there a lot of variance in it? We see that actually there was quite a variance in it. And here you see on the y-axis again the agreement, and on the x-axis 8 large language model, which had different sizes. So you might recognize there were more smaller models like Llama and Mistral, which are kind of comparable to the earlier results we saw in the literature. So with lower agreement. And we had larger and at that time more recent large language model like Claude 3 Sonnet and GPT-4o, which showed better results here. You might notice that there are also 2 columns called ensembles. best ensemble or mini ensemble. Those were integrations of multiple LLMs. So the best ensemble were integrating the extraction from the best LLMs. So here, Claude Sonnet, Haiku, and GPT-4o in a kind of majority vote. So when two of the models make the same decision, this was the decision of the best ensemble. I like to take a look now at the cost again in comparison to use those models for data extraction. Again, for on the left-hand side, there was the cost for coding all the 2,000 primary studies. And what you see is that the costs are not that high when you compare it to having research assistant or yourself doing it all the time. And when you like to conduct a quite large meta-analysis or systematic review with 100 studies, you see that it's very affordable to use the data extraction by large language model. And of course, it is very fast. I like to come to the second research question. What types of errors did the students, did the large language models make? And here we differentiated into three different errors. One was hallucination, which was when a human said the information is not included in the study, and the LLM hallucinated an information. We had incorrect extraction, so the human says the correct answer is X, and LLM says it's Y, or LLMs omitted data. So the human says the information is included in the primary study, and the LLM says it's not included. And when you look here at the percentages, you see, which might be surprising, that the rates of hallucinations is quite low. So we see here less than 5% cases in which LLMs make up information that are not included in the primary studies. What is more often is that LLMs omit something. So omitted something, that means they said the extraction said the information was not included, but in the human database, it was included. The next to look at is here the ensembles. So when you combine multiple large language model, the omitted data, the omitted error could be highly reduced to less than 1%, but it led to a higher percentage of incorrect extraction. What are the conditions of accurate extraction? So under which meta-analysis and large language model were the accuracy higher or lower? There we find on the level of the meta-analysis, especially that studies providing a very accurate, detailed codebook were better to code for the large language model, which is plausible because in those cases, the prompts for the large language model could be much more detailed and more aligned to what the humans did. The results from the large language model, I already mentioned that the bigger, more advanced model were better than the mini models. And we also found that the closed source model, closed weight model, which only runs on the servers of OpenAI or Google, were better here, but this is confounded with the number of with the size. So the closed source models were also the larger ones. And on the level on the variables, we found that the variables describing the whole study could be extracted in higher accuracy than the variables needed for effect size calculation, which could be the case because for each of the topic variables, there's only one extraction per study. And from the effect sizes, there were a lot of data coming for each study, which, introduced a new task and difficulties for the large language model, which also could be seen here in the format. So when we look at numerical data, it was less likely to have a correct extraction than in categorical data. Okay, so what did we see out of these results in summary? In the article, we derive 4 implications that could be useful for using LLM in data extraction. The first one is that in any case that you like to use those methods, they are not perfect, and it's very important to have a mandatory verification step for every LLM extraction. So a human has the final decision. What is the correct extracted value? Then we see it's good to use the best LLMs available, at least at that time. We saw that combining multiple extractions from multiple LLMs could be a way to raise the accuracy of data extraction. And like with human coders, the quality of the LLM data extraction hinges on the prompt and on the understanding of the researchers describing in the prompt clearly what the LLMs should do. After the study got published, we were very fortunate and honored that there will be 2 comments on the study that already speak about what can be learned from it. And one of those comments is especially speaking about possibilities to improve the accuracy by engaging in context engineering. And context engineering means that even more information should be integrated in the LLMs and provide a richer understanding of what should be done in the meta-analysis to improve the accuracy. And the second comment, which looks more on the research agenda, what follows now from these studies, speaks about the possibility of AI-induced automation bias. And to go beyond the variables we already investigated and look at the study quality of the primary studies. And both comments, I think, are very steps forward from our studies, and I'm quite happy that the authors brought it. What I like to present here is a second study we built on those results, and that tackle a limitation that really bothered me while doing this research, because in this comparison between human and AI extracted data, we always treated in the prior study every disagreement as an error from the large language model. But we know humans are also fallible, and not every data point, even the published ones, is correct. So I was interested in the question, how accurate are LLMs compared to human experts? And for that, we conducted a second study, which is forthcoming in Psych Review, and sampled a random sample of 150 meta-analyses from the visible learning databases, which summarizes meta-analysis focus on student achievement. And from those meta-analyses, we extracted variables only 3 here, and the number of included studies, the number of students, and the effect sizes. And what was special here is that we recoded all the studies again, so that we have not only one expert rating, but had the possibility to compare the human quality of data extraction versus the LLM data extraction against 2 standards, which here are described as educated values. That means that after we recoded all the meta-analysis ourselves, we sit together with the research team and John Hattie and discussed what is the correct value. And this was the end standard to compare against. And what we see here is a table comparing the percentage agreement on the above the diagonal and the correlation of human and AI extracted data with the final standards below the diagonal. And we see here that the LLMs were as accurate as the human raters. Both were not perfect, but to a similar extent accurate. When we look at the agreement, I brought a plot I very like. It is on the first hand a little hard to see, but I walk you through it. It shows which parts and teams of raters agreed to what extent. So all in all, there was 450 times the possibilities to agree. And when you look on the left-hand side, in 280 of times, all extracted data agree. So gold standard, the author coding, the humans, and the LLM coding. And what is special here is that you can see that also when the humans and the LLMs agree that after discussing all the values, the final adjudicated value could be something totally different. So when you may have the assumption when humans and LLMs agree, it's always correct. This was here not always the case. So summarizing the second study, we see that LLMs approached the, of course, not perfect level of expert human coders in this very specific task. So, and why did we found here so much higher values than in study 1? It is, the first thing is we had better models, only the best LLMs. Then we had more knowledge about the prompt engineering and were more clear what we like to see from the coding, and had more expert knowledge about the studies. And what I like to show in the plot before, not all agreements between humans and AI were accurate. Okay, I've brought a third study that I like to introduce shortly, which in which we use the approach for a meta-analysis on AI feedback effects. So we are extracting here from 87 manuscripts, 43 variables. All are focused on what are the effects in secondary students when they have AI feedback to improve their performances. And what we see here is that the most recent models that are currently on the market had a very high agreement of correct extraction. So here we approach 90%, which were as high as our human coders. And we see again that the hallucination rates are lower, are low, and when we have errors, we mostly see omissions. Okay, this brings me to the final discussion here, and I like to raise 3 questions that we might discuss together, or which really bothers me right now. And the first is, now we have large language model and generative AI that is as good as humans in already some cases of data extraction. At what point do we say data extracted is valid for using it in our study? What is the criteria we use for that? Then the second point that comes up more and more is when you integrate a lot of published manuscript into those large language model, um, in what circumstances is this an approach that looks on the copyright of everyone participating in writing the articles, and also the large language model provider? And the third question that is quite open, and I think will be decisive in how we do meta-analysis and systematic reviews in the future, is if we treat AI data extraction on the same level as human data extraction. Because if we say so, that AI and human coders are the same, then I think we will go to a future where most of the coding is done by AI. And when we say this should not be the case, and human coders are in a way different and more important than AI coding, then I think we have to think about ways and arguments why we say this is the case when we cannot show that human coders are all the time superior. Yeah. So this is my part of an input, and I really hope we can speak about your thoughts and those questions. Thank you.
Thank you so much. Wow, this is such needed work to really explore this new frontier that we're in. So thank you so much for that presentation, and it's exciting to hear some of the new studies that you're also conducting in this area. There's already a little bit of a lively chat in about some of these issues, but I also see a hand from Noah, so maybe we can start with you, Noah.
Hey, so thank you. I just wanted to talk about the data extraction piece because I have a feeling there's going to be a lot of discussion about the legal side of things, and I don't want to rant about that. So, with the data extraction, first, I want to say thank you a ton for your paper and your presentation today. I've been working with some of my students on this at a much smaller scale for like the last year or so, and your guys' findings basically validate everything that we found at our smaller scale of like basically it's okay, but don't trust it fully. So I wanted to say thank you for that. I'm really looking forward to seeing your guys' next papers because that question of, is a human a gold standard is the question that we're getting a lot from reviewers with our preliminary work that we've submitted and just like talking with people. So I was really glad to see that you guys are doing much more thorough work than we've done because this has been just kind of like a side project for us. The main reason I wanted to start blabbing here is because doing data extraction with AI, I think, is very challenging for a lot of people. It's very time consuming to do it well. And my team has built a like a graphic user interface that lets you do this with any AI model. And so I wanted to drop that into the chat if it's okay with you, but I didn't want it to seem like I was trying to usurp your presentation because that was not at all my goal, but rather I saw it as kind of complementary as your guys' findings are say this is something that we can be using, but the key point of our software is the human has to validate every single thing that the AI says. So before I dropped that into the chat, I just wanted to make sure you were okay with me dropping that into the chat. And if you'd rather I not, that's absolutely 100% okay. But I just know that when we started, we were like, putting things individual, like uploading individual documents and then putting in individual prompts, and that sucks. And then we started putting lots of prompts, and that also sucks. And so we developed this method that seems to be saving us time so far. And I just wanted to share it if that's okay with you all. So
I think it will be great, and we also reference this 2 or 3 times in the paper because I already found it great before.
Oh, okay. Well, we improved it since then because it was an R package, and the R package had
Yeah.
some issues with parsing. So we rebuilt it recently as a web thing so that it doesn't have that. Now it uses structured output. So it works much better than it did before while only losing a couple features. But I don't know. I can't believe you wouldn't believe the amount of like relief I felt when your guys' paper came out. And I was like, this is what I've been trying to get people to understand. I just didn't have the time or the data to do the huge analyses that you guys did on this to like actually prove the point well. So I just want to say thank you for the paper because now I just send people that paper when they ask me, can we use this to extract data? So that's all. That's all I really wanted to say. I'm sure I'll have comments when we start talking about the legal side of things because I feel strongly about local AI. But yeah, I'll stop rambling so I don't take up all the time. Thank you.
I see James has a question, so we could go to him.
Yeah, well, I was gonna ask a question that's still just about method rather than getting into like the ethical and legal stuff yet. So thank you, Thorben. I was wondering if you could you say a bit more about and this is related to like the context engineering stuff in the one of the commentaries you mentioned. Can you just give us like maybe your hot take on the context window questions and whether like whether it really makes sense or is there value in like trying to localize the information that the AI is paying attention to for data extraction purposes rather than just sort of feeding in the whole PDF?
Yeah, very interesting question. I think there is more value to provide even more context in it. So in this study, we always did one PDF for one variable in the start. So we uploaded for extracting maybe the outcome, and then we uploaded it again for another variable. And in the later works, we already uploaded the paper once for all the variables, so providing more context for each of the variables, which helped. And now I would also say that even giving more PDFs into it, so enlarging the context even wider, seems to be helpful. Because when you think about how humans we do it, we of course have read all the other papers as well. So we know what is a super large, unreasonably large effect size, or what is more or less suspected. So I think it will be more that we integrate in the end, all the PDF at once, so all the manuscript, and less that we say, please look especially at the method section at that point to enhance the data extraction.
I may have missed this, but in terms of the data extraction for effect sizes, are the AI also able to derive effect sizes from like raw data and things like that? Do you have any insight there?
Yeah, so we extracted the raw data and then calculated, if needed, the effect size ourselves using standard formulas. So I would extract everything as it's said in the paper and do inference and calculating in a second step. And don't say to the LLM, please extract everything that is needed for calculate the effect size and calculate the effect size, because it reduced the transparency in the process.
Okay, so it was in two steps: extract everything, and then, but the AI was able to take the raw data and also derive effect sizes that were checked by human effect
Yeah.
sizes, human derived. Oh, wow.
Yeah.
Because I find that to be one of the more time-consuming parts, is especially with multiple effect sizes. So that's interesting.
Yeah. This is one reason why the effect sizes were at a lower agreement when they had multiple effect sizes
Right.
that make the ordering and the connection right. Because when you look at meta-analytic data sets, the order is mostly not quite clear, but a little like the researchers do it without strong opinions in which order the effect sizes are extracted.
Betsy.
Yeah, thanks. This is really interesting. I've been around long enough to have played with automated extraction many years ago, and still I'm feeling that the view on it is it's okay, but check. It certainly was the case back then. One of the things back then that came up that I'm kind of curious about for you and your project. It's not something that you've addressed in this project, which is fine, but the assumption seems to be that the document is right. And so, either the AI can be wrong or the reviewer can be wrong, but the document is right. And of course, you're extracting from the document. So I see that as a reasonable place to start. But I think we all know that the documents are also not always right. And I'm wondering, that's, I think, it's a relatively smaller chance that the document has errors in it. But I've seen some pretty strange things in my time in documents, and they are things, for instance, that more novice coders might not recognize, and that AI would just take for granted. So I'm wondering if you can talk about whether you've thought about that issue, about whether using the disagreement between AI and the human might be a way to find those oddities in papers, or whether it really is the case that these approaches kind of take the document as true, quote unquote.
Yes. So I think if we had more manuscript that published their raw data, then it would be very much possible to look at this issue. And I would definitely, for extracting purposes, include the raw data and the analysis script at best that the authors provide and the manuscript for the large language model. So I think while prior algorithms only could start from the manuscript, those large language models have the advantage that they could also extract directly from the primary data if the study is provided. So I think this is way forward here.
Okay. One of the initial questions on the chat, and just doesn't seem like there's going to be a very clear, straightforward answer to this, but Betsy Wolf asked, how do you deal with the copyright issues, restrictions in feeding papers to LLM? For example, are open access papers fair game versus those with maybe more closed access? So obviously not any indictment on your work, obviously, but just thinking about these issues and if you ran into those, or through this process, or if reviewers or editors mention anything, just more hot takes or warm takes or anything. So
Yeah, so we think a lot about this issue, and there are multiple players in it which could have any problems with it. And I think open access, especially those open access articles that allow all also purposes for money, so commercial, I would say, purposes, those are generally fine. So this would be included also to put into proprietarian large language model. Another way to be very on the safe side is, on the legal purposes, is to use self-hosted large language model, which are now as good as the language model I showed in the first study. So like Gemma or the OpenAI open source model. Of course, this is not as convenient as just put it in the interface, but it's doable. So this would be also on the very, very safe side, self-hosting the large language model. The next step where it gets into the discussion area is when you have used the API from the large firms like Google or OpenAI, you can opt in for the possibility that they don't use your data in any way. And this, when you have this option and put then the studies in, it fails at least in Europe. Our discussion goes here on the right to use the data for for meta science. If you just but this is the discussion and the gray area. And from the not the publisher side, but the company side, so Google or OpenAI, they say you are not allowed to use it for effective mass extraction of something. So when you put in a very, very large corpus, they don't define it what is very large here. And if 1,000 PDF is large compared to what they do with the internet, then they say it's a problem from the company side. So there is discussion about that.
I'll just chime in just to be totally clear, right? None of this discussion constitutes legal advice. And
Yeah, of course.
If you have specific questions about this, you should talk to your institution's legal counsel.
Thank you, James.
Yeah.
Yeah.
It's also, I mean,
Yeah.
it's also relevant because like the copyright issues are quite distinct between Europe and the US. And so I have gotten like very different answers from colleagues that are working in the European context from folks that I've talked to here. I think here there seems to be well, actually, let me phrase this as a question. My impression is that the sort of fair use arguments, right? That setting us, as long as you can say take the PDF and have a reasonable expectation that the data is not going to be used for model training, right? It's just a query. The US folks that I've talked to seem very confident that fair use doctrines cover the case of just feeding the PDF and getting a prediction out of the model. But some folks I've talked to in Europe seem less comfortable with that. Is that your impression too, or it sounded like your interpretation might be a bit different?
I think it is in line with that, when you may have to make sure that the models are not trained on the copyright So this should be the minimum to do. Of course, in Europe, we are always hesitant to every kind of data security. And yeah, so I get also opinions from every kind of the spectrum there, and no clear point by now.
Great. And any additional questions?
Noah, your comment in the chat there broaches the question about sort of computational reproducibility.
I think that's a big issue. So like in this, and it's a hard conversation to have in a short period of time because unless you're like a super LLM nerd like I am who plays with these things for fun, it won't make some of it won't make sense. But like there's questions that I have around the parameter settings of these models and what people set them as. And so I'm very much a fan of transparency if you're going to use these models, which is part of the reason why I like open weight outside of the data privacy perspective. Like what I was gonna pitch in because I had originally undid my mic. I was gonna say if you haven't played with local models, it's worth taking the time to try it because chances are your computer can run a model that does 99% of what you want to do without having to send your data to any big company. And if you want to help getting started with that, just send me a note. I'll put my email in the thing, and I like helping people with that kind of thing because it's fun for me. It's like a weird hobby. But anyway, when you start using these models locally, you start to see all the different parameters that they have. So like context window is one of them. And just because a context window is big enough doesn't mean it actually performs the same all the way across that context window. So the question that came up earlier was like send all the PDFs versus send one PDF. So like I've always sent one PDF because I was worried about context window. But even then, depending upon the model that you're using, it may still be a problem. And so those are the types of things that I think are really important for reproducibility. Because if you just say we use GPT 5.4, what day did you use GPT 5.4? Because they might, like when it first gets launched, it might be at FP16 or some really high performant quantization. But then over time, they might drop it down to like maybe Q3 because it becomes cheaper. And they're never going to tell you that that's what they did. So like that's one of the reasons I try and push people towards using open weight models because you can say, I ran this model at this quantization with this context window, with this temperature. Like you can give people the exact information to reproduce everything you did. And it's an LLM, so it still may not reproduce it because it's an LLM, but it's at least a heck of a lot closer than it would be if you're like, I just send it to GPT-5 or I just send it to Claude. I hope that makes sense. I know I have a tendency to talk in circles when I'm excited about things and think it's interesting. So, but yeah, I hope my takeaway I wanted to get across is not all the models are going to perform the same. And I think open weight models are the way that I would encourage 99.9% of people to go. And chances are your university already has open weight models running on their servers and you just might not know about it. I know that at Florida, that was the case, is like we already had all this infrastructure and everything up and running. All I had to do was ask about it. And they're like, oh yeah, here's the API key. And like IT people can help you get set up running models at your institution if it's already there. So
Yeah, I like to underscore this. And I think what is for the open weight models, or the own hosted models, a really advantage is that you can run them many times and get not only one data extraction point, but a distribution of them. And we think currently that when the distribution is very narrow and when you have lots of runs from multiple models or multiple prompts, then it gives an indication that it is better when 10 out of 15 or 20 out of 25 models agree on the same data extraction point. And this, I think, will help us to define at what point is the data extraction valid if we say from a larger amount of data extraction points, then we tend to agree or we see a lot of agreement in the distribution.
Okay. I'm going to wait 15 more seconds. That's the time you have to wait on Zoom for questions. Okay. Well, thank you again, Thorben. Maybe we can give Thorben a virtual or audible applause there. Thank you so much for coming and sharing your work. It's super fascinating. I'm glad people are really investigating into this, and yeah, maybe my grad students will stop complaining to me about all the data extraction work that they have to do. So no, they'll still complain. So, but anyways, thank you so much. Thank you again, everyone, for joining us as well. Hopefully, we'll see many of you in LA if you're able to make it out there. And have a good weekend. Take care.
Yeah.